Predatory pricing and limit pricing are two aggressive pricing tactics used by firms that already have or hope to obtain market power, but they differ in purpose and execution. Predatory pricing is a short-run strategy where a dominant firm deliberately sets its price below its own short-run cost, often below average variable cost, to drive rivals out of the market or to prevent new competitors from entering. The goal is to create a temporary loss that is later recovered through higher monopoly prices. Limit pricing, on the other hand, is an entry deterrence strategy where the incumbent sets a price low enough to make the market unattractive for potential entrants, but high enough to stay above its own cost and earn a normal profit. The incumbent never intends to lose money. Instead, it limits the price to a level that keeps the entrant's expected profit negative or zero. In everyday language, predatory pricing is like a bully who pushes a smaller kid off a swing and then later charges a high price for the ride. Whereas limit pricing is like a homeowner who keeps the garden gate slightly ajar, low enough to discourage new gardeners from moving in, yet still enjoys a pleasant view. For predatory pricing to be feasible, three economic conditions usually must be satisfied. Cost structure: the predator must have a cost advantage. For example, lower average total cost, or ATC, or lower marginal cost, that allows it to sustain prices below the rival's cost for a period. This advantage can arise from economies of scale, superior technology, or vertical integration. Intent: the firm must deliberately aim to eliminate or deter competition, not just clear inventory or respond to a temporary market shock. Intent can be inferred from internal documents, pricing policies, or a pattern of sustained low prices. Recoupment horizon: the firm must be able to recoup the losses incurred during the predation phase by later raising prices above competitive levels for a sufficient period. The expected discounted profit after recoupment must outweigh the accumulated losses, otherwise the strategy is not rational. In simple terms, a company will only sacrifice profit now if it expects to earn a bigger profit later, much like a farmer who plants a fast-growing crop to shade out weeds, then later harvests the main crop at a higher price. Antitrust authorities evaluate predatory pricing using a two-step test, but the exact wording varies across jurisdictions. United States Sherman Act: the plaintiff must prove the defendant priced below an appropriate measure of cost, usually average variable cost or marginal cost, and B, there is a dangerous probability of recoupment. The burden of proof lies with the government, and the standard of proof is clear and convincing evidence. European Union Article 102 TFEU. The EU requires proof of a price is below cost, often using the cost-plus test, and B, a strategic intent to eliminate competition, plus a capacity to recoup. The EU also looks at market structure barriers to entry and the duration of the pricing. Canada Competition Act: Canadian law mirrors the US test, but adds a focus on whether the conduct was anti-competitive and whether it was likely to cause a substantial lessening of competition. Across all regimes, the key evidentiary elements are cost comparison intent and the ability to recover losses. The burden shifts slightly once the plaintiff shows below cost pricing. The defendant may have to demonstrate that recoupment is impossible, a defensive burden. Consider a simple monopoly that sells a product with constant marginal cost, C equals $10, and average variable cost of VC equals $12, due to a fixed overhead component. The incumbent decides to price at P equals $8, which is below a VC. Assume the market demand is Q equals 1,000 minus 20P. At P equals $8, quantity sold is Q equals 1,000 minus 20 times 8 equals 840 units. The firm's short-run loss is loss equals open parenthesis P minus a VC close parenthesis times Q equals open parenthesis 8 minus 12 close parenthesis times 840 equals negative $3,360. If the predator expects to raise price to monopoly level P star equals $20 after the rival exits, the profit per period after recoupment will be open parenthesis 20 minus 10 close parenthesis times Q star, where Q star equals 1,000 minus 20 times 20 equals 600, giving pi equals $6,000 per period. Suppose the discount factor per period is delta equals 0.95. Present value equals pi divided by open parenthesis 1 minus delta close parenthesis equals 6,000 divided by 0.05 equals $120,000. The break-even condition for predation is present value greater than or equal to accumulated loss. Since $120,000 is much greater than $3,360, the recoupment horizon is comfortably met. This illustration shows how to compute loss, price-cost gap, and the discounted benefit that justifies predatory pricing. If the loss period were longer, for example, 2 years of sub-cost pricing, the accumulated loss would double, and the firm would need a higher future monopoly price or a longer recoupment window to satisfy the break-even test. Limit pricing is a forward-looking maneuver. The incumbent does not want to incur losses. Instead, it chooses a price low enough that a potential entrant's expected profit from entering is less than or equal to zero. The logic can be compared to a landlord who sets rent just below the level that would attract a new competitor landlord to the neighborhood. The incumbent's price may be above its own marginal cost, so it still makes a profit, but the price is limited by the necessity to keep the market unattractive for newcomers. The typical strategic steps are: estimate the entrance cost structure and demand curve. Compute the entrance profit function. Choose an incumbent price PL that makes the entrance profit pi E of PL less than or equal to zero. The incumbent may also use capacity expansion, product differentiation, or contract locking to reinforce the deterrence. Unlike predation, the incumbent's price is sustainable indefinitely. The firm does not need a future recoupment phase because it never incurs a loss. Game theory formalizes limit pricing as a sequential move game. In a Stackelberg model, the incumbent leader chooses price P sub I first. Then the entrant follower decides whether to enter and, if so, chooses quantity Q sub E or price P sub E. The entrant's best response depends on the incumbent's price. The incumbent anticipates this response and selects P sub I to maximize its own profit while ensuring the entrant's profit is non-positive. In a Carnot setting with a potential entrant, both firms choose quantities simultaneously, but the entrant only participates if its expected profit is positive. The incumbent can commit to a higher output, lower price that makes the residual demand for the entrant too small. The equilibrium outcome is a limit price that simultaneously satisfies pi sub E of open parenthesis Q sub E star close parenthesis less than or equal to zero, and pi sub I of open parenthesis Q sub I star close parenthesis is maximized given the constraint. These models highlight the importance of commitment power, for example, capacity pre-investment and information about the entrant's costs. If the incumbent cannot credibly commit to a low price, the deterrence fails and entry occurs. Assume the incumbent's marginal cost C sub I equals $5 and the entrant's marginal cost C sub E equals $8. Market demand is linear. P equals 100 minus Q, where Q equals Q sub I plus Q sub E if entry occurs. The entrant's profit if it enters and chooses quantity Q sub E is pi sub E equals open parenthesis P minus C sub E close parenthesis times Q sub E equals open parenthesis 100 minus Q sub I minus Q sub E minus 8 close parenthesis times Q sub E. To keep the entrant out, the incumbent wants the entrant's maximal profit, obtained by choosing the best response Q sub E star equals open parenthesis 92 minus Q sub I close parenthesis divided by 2 to be less than or equal to 0. Substituting, we get pi sub E max equals open parenthesis 92 minus Q sub I close parenthesis squared close parenthesis divided by 4 less than or equal to 0. The only way the square term is less than or equal to 0 is when 92 minus Q sub I equals 0. That is, Q sub I equals 92. The incumbent therefore produces Q sub I equals 92, which yields a market price P equals 100 minus 92 equals $8. At P equals $8, the entrant's marginal cost equals price, so its profit is 0. The incumbent's profit is pi sub I equals open parenthesis P minus C sub I close parenthesis times Q sub I equals open parenthesis 8 minus 5 close parenthesis times 92 equals $276. Thus, the optimal limit price is $8, exactly the entrance cost. Any higher price would give the entrant a positive profit and induce entry. Any lower price would unnecessarily reduce the incumbent's own profit. This numeric example illustrates how the incumbent solves for the price that makes the entrant's best response profit non-positive. From a welfare viewpoint, predatory pricing can be socially harmful despite its short-run consumer surplus gains. The initial low price transfers surplus from the predator to consumers, but the subsequent monopoly pricing after rivals exit creates a deadweight loss that can outweigh the early gain. In a simple diagram, the welfare loss equals the area between the monopoly price and the competitive price, minus the consumer surplus gained during the predation phase. Limit pricing, by contrast, typically results in a price that is higher than the fully competitive level but lower than monopoly price. Consumer surplus is reduced relative to perfect competition, yet the market remains contested, or at least potential competition remains. The welfare cost is the price-cost margin left on the table, because the incumbent restricts output to keep the entry barrier high. Overall, predatory pricing tends to have a larger net welfare loss because it eliminates competition altogether, whereas limit pricing preserves the threat of competition, limiting the monopoly distortion but still producing a moderate inefficiency. Empirical studies, for example Mata and Destriel 2007, find that limit-priced markets retain more consumer surplus than markets that experienced a predatory episode. Sample exam questions. Multiple choice. 1. Which of the following price-cost relationships most clearly signals predatory pricing? A price equals average variable cost. B price less than average variable cost. C price equals marginal cost. D price greater than average total cost. 2. In a Stackelberg limit pricing game, the incumbent chooses a price of $12. The entrant's marginal cost is $10 and demand is price equals 20 minus quantity. Will the entrant enter? A. Yes, because profit will be positive. B. No, because profit will be 0 or negative. C. Yes, but only if it can lower its marginal cost. D. Cannot be determined without knowing fixed costs. The short answer. 3. Explain why a firm needs a recoupment horizon to justify predatory pricing. 2 to 3 sentences. The firm must be able to recover the losses incurred while pricing below cost by later charging higher prices. If the discounted future monopoly profits are less than the accumulated losses, the strategy is not profit maximizing and therefore irrational. 4. List the 3 elements that a plaintiff must prove under U.S. antitrust law to succeed in a predatory pricing claim. Bullet list. Prices were set below an appropriate measure of cost, usually average variable cost or marginal cost. The firm had a dangerous probability of recouping the losses. There was intent to eliminate or impair competition. Calculation. 5. A dominant firm has marginal cost equals $6 and average variable cost equals $7. Market demand is quantity equals 500 minus 10 times price. The firm charges $5 for 2 periods loss-making and then raises price to $15. Compute a total loss over the 2 periods. Be present value of the post-predation profit stream, assume discount factor 0.9 per period, and state whether the break-even condition is satisfied. At $5, quantity equals 500 minus 10 times 5, which is 450. Loss per period equals 5 minus 7 times 450, which is negative $900. 2-period loss equals negative $1,800. After price equals $15, quantity equals 500 minus 10 times 15, which is 350. Profit per period equals 15 minus 6 times 350, which is $3,150. Present value equals 3,150 divided by 1 minus 0.9, which is $31,500. Since $31,500 is greater than $1,800, the break-even condition is satisfied. These questions test definitions, legal standards, strategic logic, and quantitative skills that an MBA student needs to master.